So now that we've talked about annuities, both present and future value calculations, so let's take a look at the concept of compound interest for a moment. We know that when interest is compounded more than once a year, and we typically express interest in annual rates, so 6% would be 6% a year, 5% would be 5% a year. You don't think about interest so much in monthly rates. 6% is 1/2% a month. So we typically think about this in annual rates. When the compounding periods are more often than once a year, then we actually find that our real rate that we paid, or the real rate that we received, is greater than the initial rate that we thought. So if I'm going to be receiving a 6% interest rate on an investment that's compounding monthly, then once I look at the dollar amount of interest I received and compare it to the amount that I invested, I find that it's a little bit more than 6%. And that's because in this case, if I've made the investment, I'm receiving that. Every time it's compounding, it's increasing the amount, and I'm actually earning interest on my interest. Well, that's the good news. The bad news is when you're paying it, you're paying interest on your interest. So it amplifies or compounds the effect. I believe that Einstein suggested this was the eighth wonder of the world. And you've certainly heard the adage about interest never sleeps, it never takes a holiday, it never gets sick. It is 24/7, 365. So the concept of compound interest is important to us. And the more often the compounding periods in a year, the greater the difference between that stated rate that we might have initially seen and the rate that we could observe might be. So let's look at some possible ways of thinking about this. First, what's annual percentage rate? Well, annual percentage rate is typically a rate stated in an annual term as a percentage interest that we're either getting or we're paying, like 6%. That's not the kind of APR that you might sometimes see when you're looking at an advertisement for a mortgage loan, because that APR takes into account some of the other costs of the loan, such as closing costs and commissions and sales spreads and such, and adds those costs to the interest expense to change what you would otherwise think of as your APR. So the stated rate on a mortgage might be 5%. Once we add all those expenses to it, it might take it to an APR of 5.6%. So the stated rate on a loan is typically going to be the annual percentage rate, unless it's something like the mortgage loan where there's some additional costs and such. So think of the APR or the annual stated rate of investment contract. Remember that if you're a bank, an investment contract is you having offered a loan to a consumer or depositor. Or if you're an investor, the investment contract might be putting so many dollars a month into a mutual fund or some such thing. So if we want to think about the annual percentage rate of a loan, we can calculate that if we know the periods per year that we're dealing with, if we know the effective annual rate, that rate that we could actually observe. So if I had this investment that I had made and I saw that over a year the $1,000 investment gave me $63 in interest income, then I might think that that's a 6.3% annual. Well, actually, it was a 6% annual rate, but it was compounded on more than once a year, so it increased the observable rate. Think about the effective annual rate is that which you can observe, and the annual percentage rate is that which we're given. So let's assume here that I actually found that I had a 6.3 effective annual rate. So an EAR of 0.063. I wanted to know the annual percentage rate on this. So I'm going to go ahead and motivate my equation. In this equation, M stands for the number of periods per year. This is different than the N that we've seen in the other time value of money calculation. So let's think about this. I'm going to take the equation, annual percentage rate is equal to the number of periods per year times 1 plus the effective annual rate to the power of 1 over M. So essentially we're taking a root now and then minus 1. So let's motivate this. So we're going to say 12 times 1.063 to the 1 over 12 minus 1. Well, we need to calculate this out for ourselves then. So what is 1.063 to the 1 over 12, well, we probably first want to identify what 1 over 12 is, because that's to the 12th root. So 1 divided by 12 is equal to 0.08333. I'm going to store that value into my calculator storage function so I can then go ahead and use it. And I'll say 1.063 to that power be 1.005. I will subtract 1 from that. Now that it's 0.005, and I will multiply it by 2. And here I see that I actually had a rate of 0.06125, or you might recognize that 6 1/8%. So what looked like 6.3% by my observation, I know was an annual percentage rate, or a stated rate, current rate, of 6 1/8%. So let's consider the effective annual rate equation now. In order to know the effective annual rate, I need to know my annual percentage rate, and once again, my number of periods per year. So let's say that my annual percentage rate in this case is 8%, or 0.08, that my periods per year are 12 again, so I'm thinking of this as monthly. And I now can go ahead and motivate my equation, which is going to be 1 plus the APR divided by M, and then that value to the power of M minus. We'll start by taking 0.08 divided by 12, which is going to equal 0.006667. That's rounded, of course. Let's add 1 to that. So we have 1.00667. And now let's take that to the power of 12, which is 1.03, and subtract 1 from it. So we find that it was 0.083, or 8.3%. So what we thought was going to be 8%, because there were monthly compounding periods, we actually observed that we paid an effective annual rate of 8.3%. This is probably important to you when you're thinking about automobile payments, lease payments of different types, thinking about returns on investment contracts. It's just important to know that if you have an annual percentage rate and you have compounding periods of more than once a year, you're going to end up with an effective annual rate that is greater than your annual percentage rate. Or in other words, you're going to see that you actually paid more interest in a year than your annual percentage rate would have suggested. Now similarly, if the compounding periods were annual, then the annual percentage rate and the effective annual rate will be the same value.